Complete the warm-up. As you complete the warm-up, fill in your guided notes.
Hi, welcome to class. In the real world, there are multiple ways to travel and still get to the same destination. In this lesson, we're going to focus on the multiple ways that you can simplify expressions, even those that contain negative exponents. Before we get started, let's review the laws of exponents. Let's talk about rational expressions. A rational expression is the quotient of two polynomials. Now, it might not always look like a quotient from the get, right? We might not even see that it's a fraction, but negative exponents can put things into the denominator when it's not quite that obvious to begin with. A polynomial, two polynomials, is the sum of monomials. A monomial is a number, a variable, a product of a number, and one or more variables raised to whole number exponents. So really what this means is one name, right? One thing. So 4 is a monomial, a is a monomial, 4a is a monomial, ab, 4a squared b cubed. As long as nothing is being added, this is a monomial, and nothing is being divided. A polynomial is the sum of monomials. That means 4 plus a. Here's one monomial added to another monomial. Monomial is kind of a type of polynomial. So this expression, the quantity 2a to the fourth raised to the negative third, the one that you guys figured out in the previous task is equivalent to this value, is a rational expression, because in the end, it simplifies to a quotient of two monomials or two polynomials. So I know I have a rational expression. By the end of this lesson, you should be able to simplify rational expressions using the laws of integer exponents. Let's get started.
Now move on to the next page. Make sure you are filling in the blanks, the lesson question, and the blanks for slide 2 on your guided notes.
Let's take a look at our lesson question. How can you simplify rational expressions containing multiple variables? In the warm-up, we dealt with simplifying expressions that contain one variable. But in this segment and in this lesson, we're going to be focusing on simplifying rational expressions that contain more than one variable. So let's take a look at some strategy. The strategy we're going to focus on is simplifying using the quotient property first. This item asks us to simplify 12 times a raised to the fourth, b raised to the negative 3, divided by 15, a to the negative 2 times b. We're going to assume that a is not equal to 0 and b is not equal to 0 because we can't divide by a 0. So the first part of this strategy is to divide the coefficients and subtract the exponents. That means I'm using this quotient rule first. So 12 over 15, let's see, we have, what number goes in both of those? 3. So 3 goes into 12 4 times. Oh, I don't even need a fraction. 3 goes into 12 4 times, and 3 goes into 15 5 times. So I just simplified my coefficients, these guys right here. And then, let's see, I'll have a to the 4 minus a negative 2 times b to the negative 3 minus 1. Right? So I end up with 4 fifths times a, and this is 4 minus a negative 2, which is the same as 4 plus 2, so it's a to the 6th, and then negative 3 minus 1, which is the same as negative 3 plus a negative 1, is b to the negative 4th. Now I need to move my terms with negative exponents, meaning I don't want negative exponents, right? To be truly simplified, I don't have negative exponents. I'm going to take this b to the negative 4th, it's currently in the numerator, I'm going to move it to the denominator. 4 a to the 6th over 5 b to the 4th. Notice that my 4 went down to the denominator and became positive. And I'm done. Now we're going to try a different strategy. I'm going to use the same expression from before, 12a to the 4th, b to the negative 3rd, 15a to the negative 2 times b, divided by, of course. And I'm going to simplify by first eliminating the negative exponents. So first, let's get rid of these negatives. So I have 12 on top, a to the fourth, that's not negative, but this b to the negative 3 is going to tell me to move this on the bottom. So that's the first thing I'm going to do. 15, a to the negative 2, b times b to the third. So I just took that b to the negative 3 and I moved it down. Now I have another one right here, a to the negative 2. So to do 12, a to the fourth times a squared, moving this up, over 15, b times b to the third. Now, I'm going to need to deal with my coefficients, right? 3 goes in here 4 times, 3 goes in here 5 times, and I end up with 4. Now look, I have a to the fourth times a squared. Now I can use product rule. Oops, not times, plus. And I get a to the sixth. Same thing down here, this is a 1. 1 plus 3 is 4. 5, b to the fourth. Either way, I get to the same simplified answer.
You should now be on page 3 of your guided notes.
Let's take another look at our lesson question. How can you simplify rational expressions containing multiple variables? So we've already taken a really good look at how to simplify these expressions when we have more than one variable. However, now we're going to take a closer look at what happens when we raise a power to a power when we have multiple variables. Let's get started. So just like in the first segment, where when we simplified with multiple variables, we had 2 approaches that we could take, I'm going to show you one of 2 approaches you can take when we raise a multivariable exponential expression, rational expression, to another power. So this particular problem asks us to simplify this rational expression raised to a power. Again, assume a isn't 0, b isn't 0, because we can't divide by zeros. First, I'm going to simplify this by first simplifying what's in the parentheses and then dealing with the power. So let's simplify what's in the parentheses. I'm going to use the method where I just use the quotient property and subtract my exponents with the same base. So I'm just taking my exponents that have the same base. I'm adding the big negative 2. I'm not dealing with this yet, so it just comes right down here. So I took the exponents with the same base and I just subtracted their exponents. 2 minus a negative 3 is the same as 2 plus 3. I end up with a to the fifth times b to the negative 7th raised to the negative 2. Now I'm going to take this negative 2 and I'm going to distribute it into the terms inside. So that's a to the negative 10th and b to the 14th. And now I'm just going to take my negative exponent and put it where it needs to be, on the bottom of this fraction. And I end up with b to the 14th over a to the 10th. So that's the strategy of dealing with what's in the parentheses first. Our first strategy was to deal with the expression inside the parentheses first, to simplify inside first, and then raise to the power. Now let's take a look at simplifying the same expression, except we're going to deal with that power first. But I notice that this isn't the same expression, so I'm just going to get rid of this 2. Let's all pretend it's not there. Here's the same expression. Okay, I'm going to deal with the power first. That means I'm going to take a squared b to the negative 3. I'm going to raise it to the negative 2. And, I'm going to distribute this into both. Remember, it's not just the b, it's both a and b, so I needed these parentheses. A to the negative 3, b to the fourth, raised to the negative 2. Now I'm going to distribute this negative 2 inside, right? I'm going to multiply everything inside. So I have a to the 2 times negative 2, right? B to the negative 3 times negative 2 over a to the negative 3 times negative 2, b to the 4 times negative 2. So let's just do that multiplication, right? A to the negative 4, b to the 6th, a to the 6th, b to the negative 8. Negatives and positives, really important here. Now I'm going to take my a to the negative 4 and I'm going to put it down here. B to the negative 8, I'm going to bring it up, and I get, let's see, b to the 6th times b, not negative anymore, b to the 8. And then on the bottom I have a to the 6th times a to the 4th. Now my exponents have the same base, so I'm just going to add them together, and I end up with b to the 14 over over a to the 10th. Same answer. So the strategy works either way. It's up to you which method you want to start with. So let's take a look at another crazier example. I say this one's crazy because I see a whole bunch of exponents. I also see this negative. I have a coefficient here. I have to be really careful. However, not however, but there's a lot of places I can start, right? I can take that 2 and put it inside, or I could deal with what's inside the parentheses first. I could start with what's inside these blue braces, and then I could deal with this part, and then I could deal with this bottom part, and then finally at the end, I can raise everything to a square. I could also raise to the square first, right? I could just deal with this first. So there's a lot of routes to take, but let's just pick one and get started. So I'm first going to raise everything to this 2, right? I'm going to raise this expression, this monomial and this monomial to a 2. So that means I'm going to write 2a to the negative 3 b squared to the negative 1 times 2, right? Over negative a squared b cubed c to the negative 2 times 2. And I end up with 2a to the negative 3 b squared to the negative 2. And then negative a squared b cubed c negative 2 to the 4th. Now, I'm going to go ahead and deal with these exponents again because I just want to get rid of my parentheses so I can start creating ones and getting things to go away. So I'm going to multiply everything inside by this negative 2 and this 4. So this is 2 raised to the negative 2 times a negative 3 times negative 2, right? Just get to multiply these together. Times b times 2 to the negative 2, right? Now down here, this negative is actually a negative 1, right? It's negative 1 times a squared times b cubed times c to the negative 2. So I actually have to raise this negative 1 to the 4th. Then I have a squared times 4, b cubed times 4, and then c negative 2 times 4. So there's a lot going on right here, but I'm going to make this look a lot cleaner really quickly, right? I have 2 to the negative 2, I have a to the 6th, b to the negative 4, over, let's see, negative 1 to the 4th is negative 1 times negative 1 times negative 1 times negative 1. That's a positive 1 times a positive 1, so I end up with a positive 1. So I'm just going to disregard this. This is just positive. Positive 1 times anything is just that thing. So I'm not going to consider it anymore. This is an equal sign, P.S. a to the 8th, b to the 12th, and c to the negative 8. Now I can deal with moving things that are on top to the bottom and bottom to the top. So I have, what's going on? Yeah, okay. So I'm going to move this 2 to the negative 2 to the bottom. Well, I'm just going to write that as a 4, right? 2 squared is 4, but the negative tells me to put it on the bottom. I have my a to the 6th over a to the 8. Actually, let's deal with this way. So 6 minus 8 is a to the negative 2. Negative 4 minus 12 is b to the negative 16. And then c to the negative 8, right? I can't really do anything with c yet because I don't have another base that has c on it. I don't have another monomial that has c on it. I'm going to start writing in green. Then I have negative exponents on top and negative exponents on the bottom. So what that tells me is I got to move what's on bottom to the top and what's on top to the bottom. So my final answer is c to the 8 over 4a squared b to the 16. Again, lots of routes to get to the answer, but just picking a direction and getting started, you just have to muscle through it. All those laws will still work.
Okay, I want you to take a second and review the lesson question. How can you simplify rational expressions containing multiple variables? Take a couple minutes and write down your answer. Now, look at the following sample answer. While your answer might not be exactly the same, did you think about the process of simplifying rational expressions containing multiple variables. Did your answer contain some of these components? Finally, let's review some key concepts. The first, when a power moves from the numerator to the denominator or vice versa, the sign of the exponent changes. We can look at the following example and see how z to the negative first power moves to the denominator and the sign changes on the exponent, and y to the negative 8 moves to the numerator and the sign changes on the exponent. To simplify a rational expression completely, you remove all grouping symbols. Make sure each base appears only once and express the answer with positive exponents. And also, it's important to remember that there's multiple approaches and multiple ways to simplify the same expression. Now let's review common problem types. To simplify rational expressions with negative exponents, first use the negative exponent property, and then use the property of exponents and simplify. Or you can use the quotient property of exponents first, and then use the negative exponent property. To simplify a rational expression raised to a power, simplify inside of the parentheses first, and then raise the expression to the indicated power. Or you can raise each factor to the indicated power first and then simplify. The big takeaway is that there are multiple approaches. I want you to use the last page of your guided notes to write down any questions that you may have so we can address them the next time I see you in class.